Hey guys, so this morning we are picking back up, continuing work on our application, and we kind of left off yesterday having started a main loop for the program here, and and now we're going to perhaps do some handling of exceptions, and also keep going on writing the functions that each kind of user can do. So you said that you started doing some exception handling. What method did you start in? Okay, well, here's one. All right, delete. Right?
Yes, I probably update. I'm not sure. Let me see.
Okay, so here's update. Yeah.
I did read as well. I didn't do get field names.
Okay, so if one of these functions that takes in the table, so the get field names function, what happens if the table name that they give is not valid? Like what is the state of the function at that point?
It won't work. So
okay, so the code won't work. That's correct, but will an exception be thrown?
no exception will be thrown. That's where I should have an exception. But do I wrap the whole thing, the if and if statements, everything in the exception?
So right now the only thing that is looking for exceptions is this line right here, right? Because if you have a try catch block and the only thing that is going to quote unquote try execution, so where you're basically looking for an exception, is going to be the top part. So you remember when we did exceptions the first time? You can try except generally, but generally you catch a specific exception, right? So
yeah.
like if, for example, Python divides by 0. So if we were to catch something here, we might do the 0 division error. So of course, that's not what we're doing here, but the point is that's kind of what it would look like, right? At least I think so. Yeah, except 0 division error. So this would be how we fix this particular problem. But the thing is, none of the calls that we're trying here, none of these will actually throw an exception. If table name doesn't exist, it just won't hit any of the things in the conditional. Actually, that should be an elif. Oops. So this probably isn't quite how we want to go about working on this here. Now, another point to make, exceptions, at least relatively speaking, exceptions are very expensive. So you have to pause execution of your program, and the interpreter, that's what the thing running the program is called for Python. So Python is not a compiled programming language. I'm not sure we really need to get into all the specifics of that, but in terms of performance, like in terms of how fast your application is, exceptions are slow. There's a lot of overhead involved in throwing them and in saving the state of the program before and after them and things. So if you can handle some cases in your code without having to throw an exception, like sometimes you can't get around it. Like if you try to divide by 0, there's one of the ways in which you can get around it is by checking if basically the second operand, the one on the bottom, you can check if that's 0 before you do the division, right? And then if it's 0, you can handle that without ever having to catch an exception. But sometimes there's really not a lot you can do. So for example, if the user is giving you a file and you can't force them to, actually, hold up. I'm trying to come up with an example that you can't get around. Yeah. You know what? It's escaping me off the top of my head, but there are times in which you can't always completely check beforehand. However, if you can check beforehand, that's usually considered the better way to do it, because that way you never even throw the exception. So checking beforehand, things that I mentioned or that I was going to try to say were unavoidable, but actually are avoidable. If you have something that takes in a file name and opens the file, well, that won't work if the file doesn't exist, but you can check for existence of the file before you open it. You can check for the length of the content in the file before you try to run through it and parse it, right? And in both cases, if you do that, you can avoid errors that would be caused if you didn't do that. So all of this is a long way of saying that I don't think having a try except block here is going to be the right way to handle a table name that doesn't exist.
Okay.
So,
okay. So not in the read record function.
not in any of them. I mean, we do get table names up front directly, but when we do want to handle, you're correct that we do want to handle the case where they try to get the field names, and the field names for the table name they provided comes back empty, does not have anything.
Okay.
So I tell you what, let's try it. Let's go. So I'm just going to go ahead and we can keep the string here because we can use that value to tell the customer. But for now, going to and the other problem with how things were here is that you see how only this line, only the print line is indented under the except, right?
Yeah.
So what happens with what you've written? What happens if there's an error in the field names function? Like, walk me through what code is going to run in this function and what code won't run.
Okay. So I was thinking it would try to get field names based on table name, and if it doesn't have the right table name, it will throw this exception and not do anything until it gets the right table name. So nothing from with open will run until it's gotten the right table name.
Okay.
But suppose one question I had is, how would it know what the right table name was? So I'm not entirely clear about what I did there.
So programs are dumb. That's an important thing for us to remember as programmers. Things that are super obvious to humans, computers don't know, because computers don't have intelligence. They're not sentient. Computers at a high level are exceptionally good at doing what you tell them to do. However, they only do what you tell them to do. And so here specifically, several things to break down. So your question of how will it know that you don't have the right table name? Good question. For us specifically, if a table name does not meet any one of the conditional cases inside of these functions, then we know it's not a correct table name, right?
Okay.
Does that make sense?
Yes.
So then the question is, how does the program know if it's not the right table name? So what happens if none of these conditional cases are met? Like, implicitly, if a function doesn't return anything, it returns I think in Python it returns the none type.
Mhm.
So if something returns the none type, does it throw an exception?
I think in that one example we had, it actually threw an error. I don't know if that's a thing it does all the time or just there.
In what specific example?
We were trying to what were we trying to do? We called, okay, yeah, we were trying to make a copy of a list and add something to the top of the list at the beginning of the list. That's what we tried to do, and it said that it was a non-type. It was expecting an iterable, and didn't get something like that. So it threw an error, but I don't know if that's the same thing. If it would do that all the time when a function doesn't quite do what it's expected to do.
So that particular error was because we were trying to iterate over something that came back as a none type. Now you're correct that a function, that an error will be thrown eventually in this file if field names comes back as none, because that's what it will come back as. It won't come back as an array, or not an array, a list, how it's supposed to here. You know, a list containing the string, like a list of strings that are the column headers, right? The names of the columns of the information. However, it won't, this line right here, and this is the point I'm trying to emphasize. The only code that this block that we have here, the try except block, is actually checking is this single line. And where I'm going with this returning none business is that this line actually will never throw an error. There is no way in the Python code for this code, I mean, unless you have some really random runtime error or something, but like no way, given how this code is set up, that it will produce an error. So that means that putting
there should be okay.
So at the very least, you're correct that eventually, if you have the field names and the field name isn't proper, or if the table name isn't proper, this will come back null. When you try to iterate over it, bad stuff will happen and so on. But that doesn't happen right here. That happens further on down in the function. So if you wanted to do the error handling this way, what you'd have to do is you'd have to wrap, the entire thing in the try. And then what this except represents, is, okay, so we're going to try to get the field names, and if any error happens in this entire thing, then we're going to print the table name you have entered is invalid. Okay, so do you see how that's at least different from how you had it before? Whereas before we were only trying to get the field names, and only if that failed were we printing an error message. But here's the thing. In what we had before, this right here, and why I was asking you to walk me through the execution of this. Okay, so I kind of got some of the reasoning as to what you thought it would do, but after it prints this message, so let's say you enter an invalid table name. Let's say you enter the table name, oh, I don't know, like managers or something. So we have store owners, but maybe they hire a different company to do the management of their stores, or a franchise or something like that. So if you have a table called managers, well, that table doesn't exist, not here. And so this line, field names equals get field names of the table name with managers, managers as a string, will return none. Okay, and then going through here, we're going to open managers.csv as CSV file. Does managers.csv exist?
No, it doesn't.
But the problem is that if that table name wasn't valid, we should have stopped things right there, right?
Yeah.
Because how you have it right now, if you try this, I mean, so first off, this won't ever throw an error. Even if it did throw an error, if you caught the error right here, even having thrown an error, the rest of this code will still execute because it's not in this block. So you have to wrap all the code that you want to stop executing if there's an error, you have to put in a try block. And another point to address, you said that you thought that it would keep having the user try to enter a table name until they got it right. Right?
Yeah.
So that is unfortunately not how try except blocks work. They don't implicitly have a while loop in them. So basically, if you fail this code, it's not going to keep trying to have you do it. If you fail this code, you fail it once and you're done. So like I said, even if you were to get an error here, because you have an except block here, this is where the error would get handled, and then execution would jump straight to line 62, as if you'd never had an error to begin with. So there is no repetitive cycle of waiting until the user gets it right inherent in error handling. Now that is almost always going to be the way in which we want to do it, right? We don't want to just give them a single chance, and if they blow it, well, too bad, so sad. Now you can't use the application. We're going to want to, not let the actual function run unless and until they enter a valid value. But that's something that we have to set up on our own. That's not something inherent in error handling in any programming language. Okay, so plenty to talk about here, right? But we said this function doesn't return errors. So first off, that's one problem. The except here, the try except block needs to wrap anything that there might be an error in, not just a specific line, and specifically the line that doesn't throw errors, right? We need to make sure that if there is an exception, we don't go on to then run things later, right? Because that's what this does right here without having everything in the try block. As soon as there's an error here, then that means that we're going to jump to this block in the except and then print this message, but then we're going to keep going. So that's probably not quite what we want. And I mentioned here that because we keep executing, if the table name isn't valid, this will come back as none. But the first error that we get actually isn't even related to that. It's related to the fact that we can't open a file that doesn't exist. So is everything I'm saying making sense? I want to make sure I'm getting through.
Yes. Yes, it's making sense.
And I'm trying not to be like super hard on you either. It's just what you had was the right sentiment. We want to check if the table name is valid, right? That is 100% the first thing that we should check in these functions. So for read specifically, we have a table name and we have an ID. This is so-called validating input. Validating input always basically like what you need to do to ensure that you won't get errors in the function, right? So first argument is the table name. We need to validate table name. How do we validate table name, right? So the impulse that you had was exactly correct. Now it's just a question of, okay, how do we do it?
Yeah. So I think so far, the thing I'm still trying to wrap my head around is when to use a try except block, the try except functionality. You said there are other ways we can handle things sometimes. So
in fact, I would wager to say most of the time. You check things before you do something that might lead to an error condition. So let me do a couple of examples. So if we were in our main file here, and let's comment out this line for a second, and we'll just do some scratch work. So if I have, I say x equals 4 and y equals 2, and then I say z is going to be equal to x and then integer division y. So I think by default division in Python isn't straight division, it's integer division, which doesn't work well if you have a remainder. because it'll like truncate it. But that aside, you agree that this should, if we print Z here, we should get 2, right?
Yes.
Or actually I should print Z, not print what it should be, right? So if we run this, we should get, right row, what line? Line 29. That needs to be indented. That needs to be. What now? Yeah, we'll come back and fix it later. We'll want to make the point. Do you feel lets me run now? There we go. So we get 2 when we print it, right? Okay, so what happens now if we turn y into 0?
I expect it will throw an error.
Okay, now it should throw an error, right?
Yeah.
Right, because you can't divide by 0. So let's actually turn this into a, function. So we might say def divide, and then we take in, that's not how you spell it, divide. We take in x and we take in y, okay? And then we are going to return x divided by y, and then we might call this as print divide 4, 2, which is what we just did, right? This should return exactly the same thing we just had. Okay, so we said that if y is 0, we're going to get an error. So one way to do this would be to do the following. So we're going to try, do the thing, and we are going to accept. Now, we don't want to just accept generally. So if we do this, there was an error, right? So we run it normally, that will happen. And if we run it with 0 here, we are going to, instead of doing this, if an error occurs in trying to do this, we're going to do this instead. That's kind of what try except blocks do. And so we're going to say that there was an error, and then the function returns none, right? So instead of doing this, we do this, but because we don't have a return statement, the function implicitly returns none. But this isn't actually very helpful to the user, right? Because if we just tell them there's an error, well, what was the error? And what happens if we could possibly have multiple kinds of errors? How do we distinguish between them? That's why, by convention, you're supposed to catch the type of error that you want to handle. So there was the 0 division. Please make sure the second argument you give function is not 0. So you see how now we're catching something specific, right?
Yeah.
And so now, because we're catching something specific, this except block will only catch this particular error. It won't catch any other kind of error. And that's how we want it. We want to not be unsure of basically what could go wrong, but we want to handle specific cases. So here we'll see that, okay, now we have our good error message, right? We're still printing the none type, but we have our good error message. But you see how we're still throwing an error, right? And in terms of what I said before, this may not seem like such a big deal here because, you know, we only have a very simple program. But if you have an application where you have a server and hundreds or thousands of users might be hitting your application, and every time something goes wrong, when one of them hits your server, you have an error that gets thrown, right? Rather than checking something on your own. That might actually add some overhead to your application that wouldn't otherwise need to be there. Because like I said, in the runtime environment, errors are expensive. They stop execution of your program. They have to keep track of a bunch of state information, and they have to context switch between like things that are running. I mean, I won't get into all the specifics, but exceptions are expensive. So usually it's also kind of just considered poor practice to rather than checking if something bad would happen up front, to just let the bad thing happen. We're going to try to come up with an example. So what would an example be? Like, okay, let's say that you're a chef in a kitchen and you're cooking an omelet, right? Now, something that could go wrong here is maybe you have the heat up too high and you burn the eggs. You following? So if you check up front, is the heat too high, right? So let's say, just for make pretend in my analogy, that we have a function called make omelet. I have no idea how you spell that word. How do you spell? Is it like 2 T's?
Yeah, well, I think it's 2 T's and an E.
How to make the perfect OMEL. Well, 2 T's? 1 T, 2 T's? It looks like either. Anyway, aside, so we're going to have a function called make omelet. It's going to take in eggs and a heat source, right? So the problem that we just said is if the heat source is too high, you might burn the eggs, right? So there'd be 2 ways to check this, right? So option 1 would be you check the heat source up front. If the heat source is too high, you don't even try to make the omelet because you know you're going to burn it, right? Option 2 is, well, you don't check heat source up front. You just try to make the omelet. And then if it gets burned, you put it out with a fire extinguisher. Do you understand the 2 paths I'm talking about in our real life example here, right?
Yes.
Which one do you think makes more sense for most people?
To check the heat source, obviously. Make sure.
And so the try except in programming is the equivalent of knowing that a fire might happen if you have a really hot heat source. And so instead of just checking the heat source, you put a fire extinguisher next to it instead. That is more or less what the try except catch. Now, there are times, like I said, I know I'm being really vague because I was having a hard time coming up off the top of my head with an example. There are times when you can't figure out what could go wrong up front, in which case you need to wrap it, because what happens if a bad thing happens? Yeah, I mean, here's an example. If you're going through line by line, if you're reading through a text file, what happens if one specific line of the text file is corrupted? It has bad data or something. Then you might, well, actually, most of the time, the file would throw an error when you know what, regardless, even if I can't come up with an example, you're just going to have to take my word for it. There are times when you will be doing something and an exception might get thrown. And if you don't elegantly handle it, bad things will happen. But a lot of the times you can check things up front. You can do the equivalent of checking the heat source before you try to use it. And that will let you determine if an error would occur, right? This is a contrafactual state, a hypothetical situation that might occur. And sometimes it's really hard to figure out everything up front, right? You'll get a lot better at it as you get more experience as a developer, being able to figure out what could go wrong before you even run your code. But for the first little bit, you don't even know what kinds of errors there are, right? Like you don't even know the possible error states. And when you're in that position, it's kind of hard to write proper checks all up front. But that is considered the better way of doing things, right? So in our physical analogy, this is why I like to use analogies, because usually it makes a lot more sense to people when what we're talking about isn't code, but it's something like concrete and easy to understand, like making eggs, right? And so, like I said, just how most people would think you're insane if rather than just checking if you're going to burn the eggs first, you just have a fire extinguisher ready to put out the fire if you do burn the eggs, right? That doesn't make a lot of sense. Well, it's exactly the same thing in code. So hopefully that example will stick in your head now of whenever you're thinking, okay, if I have input of a certain type, it might cause problems for my function, right? So should I check the heat source or should I put a fire extinguisher in my code, right? That's how you're going to want to think up front.
So it's going to be using conditionals before using try except blocks.
That is a good generalization. Yes, you're going to want to check the value of whatever it is that you're concerned about with a conditional before you try to use a try catch block, or not even, it's not like, usually the two things are mutually exclusive, like you do one or the other. But that wants to be your first approach. Like like in terms of things that you might try to implement, it should be higher on your list of something to try to implement than the actual explicit error handling like this. So in terms of what we're doing here, where we have our try except block here with field names, rather than a try and an except here, let's, I think I saved the message that you had somewhere, but for now, we're just going to have the code be like how it was before. So with no error handling whatsoever, this is what our function looked like, right? So now we want to do the equivalent of checking the heat source. So the heat source, the thing that could be wrong, the thing that could give us problems here, up front that we're checking is table name. And so we said conditional rather than error checking. So if table name then we would want to print that we have an error message, and then we would want to actually return at this point. We don't want to return anything. We don't want to keep going, right? Because if we know that table name's a problem and we know that there's going to be problems, we don't want to keep going, right? And actually, eventually, as you said, the problem with trying to put a while loop here inside this function, like while not invalid or something. I mean, I have pseudocode here, but the problem with doing something like this is this was given as like an argument to the function. So I suppose you could like have the user like update the value of this variable or something, like in the loop. That's just kind of confusing. So normally what this would be is you might wrap this entire thing in a call. So this is what we might try to do here. Now, I will tell you, this is a trick question. If I ask you what value of table name here should we be checking? You know, how do we know that table name's an error, right? Do you remember before I said that we know table name's an error if it doesn't meet any of these conditional cases, right? So we know table names is an error if field names, the call to this function returns none. So what's the problem with what I've written so far?
We don't really know whether there's anything wrong with the table name.
Right. On line 58, we've just entered the function. We have a value for table name. We have a value for ID. We have no idea if something's wrong with table name or not, right? Yes. Because from the point of view of this function, functions kind of, they only know their own thing, right? They only have access to their own function scope. This function can't peer inside this function and know what's going on. So on line 58, we have a value for table name. We have no idea how to check if it's valid or not, right? But we said that field names is going to try to get table name. And so actually, this is where a lot of the times it's really hard for new developers. Rather than checking the variable called table name to determine if table name is valid, in this particular function, we are going to be checking the field names variable. So specifically, what value should we check in field names if we want to check if an error situation has happened? What will field names return if the table name they are trying to access doesn't exist?
I'm not sure.
So implicitly, none of these cases will be hit, right? So it won't take this path, it won't take this path, it won't take this path, which means that you get to the end of the function, it hasn't done anything. And in Python, this is Python behavior specific, not all programming languages working exactly the same way. In Python, if you don't return anything from a function, Python implicitly returns the none type. That's what we're saying. It says, so basically basically what I'm saying is that if you get to the end of this and nothing's happened, it's exactly as if you had written that in your code. So if you don't write this in your code, it's like Python adds that to the end of every function where you don't return anything. So here specifically, we're going to say if field names is none. If we get equal, at least I think this is how you do it in Python. I have to check. In C#, we have something called null, which is the same thing, basically. So if field names is null, we're going to print in error message here. Actually, I deleted it, but you had the actual message somewhere. Where did we save it? Saved it right here. Table name you have chosen is invalid. Please choose another table name. So that's an okay error message. It's descriptive, tells the user what the problem was and what they can do to fix it, right? Those are usually the things that you want in your error messages. You want to tell the user what the problem is and how they can fix it. Because if you only tell them what the problem is, that can be really frustrating, right? Like the table name you entered is invalid. Okay, great. But how do I enter a valid table name then, right? So that's a common pitfall. If your program has good user experience, you'll have error messages that both tell the user what happened and how they can deal with it rather than only telling them what happened. Programmers, probably it's kind of obvious to us how you deal with it. Oh, you just pass the function a valid thing, right? But what happens if you're a user? And you don't, like all of this code stuff's kind of magical to you. It's a black box. You don't know how it works. So things that we think are obvious won't be obvious to normal people. And so basically, you need to start thinking like you're a dumb user. That's, I mean, it sounds really mean, but when you're on a development team, we laugh about this a lot. It's not that our customers are specifically trying to break things. It's just not being the ones writing the code. Some of the assumptions that we kind of make implicitly just aren't even on their radar. And so this is actually a really huge problem in software engineering. The people who write the application it's actually harder for them to break it. They have to like really try intentionally because they're the ones who wrote the code. They know what it's supposed to do. And so they know how to use it properly, right? Because that was the whole point of why they wrote it. It's someone who doesn't know how to use it properly that's likely to go, send an input that doesn't make any sense whatsoever if you actually understand what it's supposed to do, but they don't understand what it's supposed to do because they don't even see it, right? That's the thing. So we need to put on our dumb user cap and see if we can figure out, if I were being really silly, what would I pass this function, right? Because for us as the developers, we look, oh, look, here's the table names. Let's pass it one of these, right? But the problem is the code will always work if you pass it one of those because those are valid table names. What happens if you pass it something that's not a valid table name, right? So 3 code branches. I know I've mentioned before how important testing is. Even if not unit testing, at least functionally testing your code, you will almost always have 3 cases for any given piece of code that could possibly go wrong, right? If it's something really easy that can't go wrong, well, then you don't have a case for it. But anytime you're interested in the value of an input that you're checking, you're going to want to check the good case. So the case where it's something valid. In our particular example, that means it's one of these things. It's one of the tables that actually exists. That's the valid case for table name. You want to check the invalid case. So they give us a table name that doesn't actually exist, right? The example I used before was managers. There is no managers table. So they give us managers. It's a string. It's a table name. But managers just doesn't exist. It's not a valid table. So valid, invalid. And then the other case to check is the null case or the none case, where they just give us a table name that is nothing, right? It has no value. And if table name has no value, none of this will work. So there's the case where they give us a good table, the case where they give us a table that would otherwise be okay, it just doesn't exist, and then the case where they just don't give us a table at all. Good, bad, null. You will almost always have to check those cases when you're doing input validation.
Okay. So at this way you wrote return, it would be return read record, right?
What do you mean return read record?
Is that all we need to put in there?
So if we don't say explicitly return anything, this is what it returns.
Okay.
So what we want to
And
do
the
is we
idea-
want to stop execution,
Yeah,
right?
that's what I was going to ask. So that's what we're doing there.
Mhm.
In execution of the following lines.
Yeah.
Okay.
So if you don't put an actual thing after return, you just implicitly return nothing.
Okay.
Now I mean, you can write this. It'll work just fine if you write this. It's just most people will look at you kind of weird because this is just something that, as a developer, if you just return, so Python calls it returning none. In C#, they use the word void. If a method is void, it implicitly returns null. It's very common in programming languages for if you just have the keyword return and you don't write anything after it, for it to return some default value, null, none, whatever.
But it would still print that statement.
In fact, we can try it. There's no reason why we can't. Okay, so let's say we want to print and we want to read the record in the stores table. So we have one record in the stores table, Ariel's baked goods, right? So we want to read the record in the stores table and we want to read the first one. So this should work fine, right? Because stores is a table that actually exists. Let me come down and we'll comment out our discussion here of talking about errors a little bit more. So in our read record, this should be fine. We should get Ariel's baked goods, right? Now, what happens if we misspell stores? So rather than stores, we say stars. So someone's having a bad day and they don't type in the table name correctly. Given what we just wrote, what do we expect to have happen now? Walk me through it.
I would expect it to print the table name you have chosen is invalid. Please choose another table name, because when it calls the function for get field names and enters this if the conditional, the if block, if the field names, as in if the function that it calls does not have anything like stars in it, then it's just in that statement and end there.
So it's going to print that statement and end there, right? Okay. So the table name you've chosen is invalid. Please choose another table name. Because we're printing this value, we're going to get the value none because of this return right here, right? So I'll watch. This value will change. So right now we're implicitly returning none. If we return the string foo right here, this will become foo. See? Because where that's coming from is we're returning the value that this function returns, right? And we control that value right here. Most of the time, if an error case like this occurs, sometimes depending on the programming language, sometimes people will return -1 to show that an error has occurred. But a lot of the times people will just leave it as none because we don't really care, right? We don't really care what the value is. We just care that an error returned like this, right?
Okay. So if we didn't want the execution to end there, what do we?
Okay, so one option is we write a while loop inside this function, right?
Okay.
So another option is that we put the execution of this function itself in a while loop. Do you see how those two things would be different?
The first one just puts that the if block in a while loop or the whole function.
Okay, I think we better write it then. So I'm going to go real fast here just because it would be good if we got an example of how this would work. So inside here, we decided that we want to not let the rest of this code execute until they have a valid table name, right? That's what we're trying to do conceptually. So what happens if the table name that they give here is invalid? So we would do this. What we would do is we would say while, and then inside of our condition, get field names, table name. So our condition is going to be while that returns none.
Okay.
We are going to please print, or not print, please provide a valid. Then let me come down to our main program loop. Where is our input? Input, we use the end blank here to get rid of the new line implicit in the print statement so that their input will follow right after this. And then we say user, we say user to be then we say table name is going to be equal user input. Or you could just say table name equals input directly, right? But this perhaps makes it a little clearer what we're doing here. Does this make sense to you?
Yeah. Yeah.
Okay, so we're going to say while our call to this function returns none, we want to keep asking the user to give us a valid table name. Okay, so let's uncomment this call. This should jump into this while loop because the very first time we try to get field names with the table name of stars, we have no table called stars. So get field names of stars should return none. We shouldn't get anything here. Okay, so that's why we jumped into the loop, right? And if we give it bad stuff, it's going to keep telling us, please provide a valid field name, right? Now, if we give it stores, I see. So
is it because we commented the first few?
No, it's because we never assigned the value of this. We never assigned the field names equals get field names table name. So because I took that line away.
Okay.
Because later on down, we're trying to use a value called field names, but we never assigned a value to it here.
Okay. Okay. So it has to be in the while loop.
Okay, so still same behavior. Now it works fine because now we give it a value. Okay. Does this way make sense then? Okay.
Yeah.
So we have the while loop, we check it as a while loop inside the function. So that is one way. The other way that I was mentioning was we could have it external to this. So right now, this function as written right here will always return, it will always return none if the table name they give us isn't valid. Okay. So in calling it, rather than just calling the print here, we would do something like I don't have a do while. Annoying. I don't think it does. Oh well. Okay, so where am I? Right here. This. Okay, so so we're going to do all this, and then we're going to read records with table name. And then the other input here is the ID we want to read. And so we're just going to say ID1. We're going to say, well, what do we expect this function to return if it returns the right thing? I'll give you a hint. We still have it in the output over here.
Okay. Okay. While read record returns Ariel's baked goods.
No, the point was we wanted to actually return something, right? Okay. It's going to have a value. It's going to be a string containing a comma separated list, or the list of the values separated with bars in between, right?
Okay.
But most notably, what it will not return, if it was a good read, is it will not return none, right?
Okay.
Because if the read is valid, it's going to return something, right? It's going to return the list of fields.
Okay.
Why I was looking for something called a do while is because it lets you define something that you do as long as the record is like not the case. Like you do it up front the first time, and then you try the while condition. Fortunately, Python doesn't really have it, so you have to like copy paste this twice. But so once we start executing line 89, we're going to print, please provide a valid table name, and then we're going to let them input it. The user can input the table name. We get the table name. We try to call read record with the table name. If read record with the table name returns none, then we make them enter another table name until read record doesn't return none. Okay. So if we run this, please provide a valid table name, right? We keep, now we get the error message from inside this function. That error message is coming from right here. And then we return, and now they're going to input another one, right? And now we input valid table name finally. And
why does it say that?
Yeah, that's what I'm wondering, because we wouldn't expect this to be, invalid there.
Invalid.
Huh. It's probably something really silly.
But it worked before.
Well, when we had it inside, yeah. I mean, this will work too. I want to get a working example. I have to go pretty soon here today. I don't want us to leave off on like a not working state, but you could do the while loop inside. You can do the while loop outside like this as well. I hope you see that.
Yeah,
whatever the reason for me not having this work properly right here. Yeah, I'm still not entirely sure why. It's probably something goofy, like I said. I wish the debugger worked. Maybe we could give it a whirl here. Although we haven't had particularly good luck with the debugger in this application. Yeah, seems like it's not going to work. Oh, and now we just crashed it. Lovely. Let's try to trace through this manually. So please provide a valid table name. We give it a valid table name up front, while read record table name is equal to none. So we give it the table name stores. We didn't print anything like we would expect if this was successful, but we also didn't get an error case inside read record. Okay, so field names is fine here.
Okay. So what changed?
I got it. It's because it is actually succeeding, but see, if we print stores there. Huh. So if we print table name here, yeah, you know what? I really do have to go probably. So
Okay.
I'm sorry to leave us hanging like this. We'll have to figure out what's wrong with this. I don't know why. Like I may try to open it in a real debugger because this is not the most fun to try to debug with print statements here.
Okay.
I'm trying to figure out why it would, like, why would we be having issues here if what we have is valid? What does it think we get? Does it think we get? Oh, it's an indentation problem. Look at that. Everything else is indented too much. See?
Okay. Okay.
Did I do that just now though?
The indentation?
Yeah. Because why'd the other one work?
Yeah.
Oh, I don't know. Let's try now.
Still doesn't work.
I mean, that was wrong though.
Yeah.
So let's see if it does it let us get inside the place where we're opening the CSV file? Yes. Okay. Does it let us get inside? Oh, I know what it is. I know what it is. One of the other things that we should set up validation for. I'm going to see if you can spot it as well.
Okay.
I'll give you a hint. It's a problem with one of the arguments that we're passing. And that argument is not table name. So
Oh yeah,
process of
I've seen
elimination.
it. Yeah.
You know what it
One.
is?
Yes. The ID.
Gotta be a string. Okay, so I think Python is smart enough to let us do this. No. Rats. So what we want to do is you want to print this, right? You want to print it, but only print it if it's valid. So to be smart, what we're going to do is we're gonna say the this is kind of sloppy because I'm going fast here, but does what I just did make sense? We want to be able to have a value of the variable that we're checking here so that we can print it at the end. So everything that we just had there was because we weren't passing an argument of a correct type. So now if we input gibberish, we get the correct error message, right? If we input stores, it's going to print it out and then terminate. So all the previous errors were caused because we were not giving that a string, we were giving it a number, which we need to give it a string, and we need to provide error checking for that on all of our functions as well.
Okay.
And then,
just to get this clear, when we talk about error checking, it's not necessarily using try except blocks. We can do that with conditionals.
That is correct. And in fact, much of the time it's preferred to do it with conditionals upfront. And if you ever get puzzled as to why, remember our analogy with the eggs and the heat source, right?
Yeah.
Do you use the fire extinguisher approach or do you use the let's not burn eggs approach to begin with? So much of the time, in fact, checking for error conditions should be done with conditionals before you even do any execution. And what I've shown you here is that you can do it outside of the function like this. You can also do it inside of the function. So let me briefly, I want you to think before I go today, which one of these do you think is generally going to be considered better? So for one thing, this has less lines of code, but that aside, what happens if we call this function 10 times? How many times do we have to write this right here?
If we call the function 10 times. I don't expect we would have to write it more than once.
Okay. Now, how about if we call the function 10 times and we want the checking customer import, how many times do we have to write this version?
It looks to me like we'd have to write it every time because of ID.
Not because of ID. We have to call it every time just because that's how we're checking their input right here, right?
Okay.
So, yeah.
Okay.
On that basis alone, that should tell you which one is better, right?
Is better, yeah.
So here specifically, because we can concentrate it inside the function, and we only have to write this once. And then anytime we call this function, doesn't matter from where we call it, anytime we call this function, then
it's going to do this.
Definitely the better approach. But I wanted to show you that you can do it either way. Both of them will work code-wise. It's just maintenance wise, this is a nightmare because you have to copy this every single time you call it versus this is just inside the function itself.
Yeah. No,
Okay.
I understand.
So you now have a working example of checking table names up front and then not letting any of this other stuff execute until they get a valid table name, right? So you should be able to do that for all the functions that take in table names. And remember, we saw the issues with not checking this just now as well, right? So you're going to want to check ID as well. And you're going to want to make sure that the ID that they have is a string. And if what they give us isn't valid, then you want to get another ID. And you should have a direct example right here with table names, right? So
we use, okay, probably tying the two error checks together would not be very wise because someone could get the right table name and the wrong ID or the right wrong table name.
And then you'd have to figure out which one they gave was wrong. Doing it in two separate loops makes sense in my opinion.
Yeah. Okay.
All right. Well, hopefully this has helped get you more. You're going to want to be doing this for all the things that take in table names, which is most of them, I think. And then now, one thing worth pointing out is that since we're doing our checking here with the table names, we don't actually really need any error checking in these functions, right? Because it's absolutely fine for these functions to have a table name that doesn't exist and then just return none. That's fine. Like, doesn't cause any problems. It's down here where we want to like open something based on the table name and do stuff that we need to check it. So, all right. So today, lots about error handling and validation, and our analogy with the chef making eggs hopefully will help you understand that it's usually better to try to check up front rather than try to handle it after something bad's already happened. Okay, well, that's where we'll drop for today, and we'll pick up tomorrow and see if we've done more validation on all these functions that we have here.